Hello, my name is Kumararaja from BND Department FTK. So my supervisor's name is Mr. Magad Satria Zainuddin bin Yaqub. So I'll be presenting my project IoT-based automated aquarium system. So let's start with my abstract. So fish keeping can be fun and a well-established hobby in a vast variety of marine lives as with a vast variety of marine lives to be kept and enjoyed. Fish keeping can also be physically and emotionally confronting, as watching aquarium can help people to relax and make beautiful decorations. However, maintaining an aquarium requires consistent efforts and knowledge, which can be challenging for aquarists who are not always be able to monitor their fish tanks. To address this problem, an IoT-based automated aquarium care system has been developed with an objective of developing a system that is reliable and maintains the aquarium's health even in the owner's absence. The system incorporates an auto feeder, battery-powered aerator, and a water change mechanism, all controlled and monitored through Blynk app. The project successfully achieved its objectives, enabling precise feeding, vital oxygen exchange, and water quality maintenance through rigorous testing and implementation. Moreover, the system operates efficiently during power outages, ensuring continuous functionality. With remote monitoring and control capabilities, users can easily access the systems through the Blynk app. The IoT-based automated aquarium care system provides a reliable and efficient solution, elevating the burden of aquarium maintenance while promoting the health and safety of marine life. This project highlights the significance of automation in aquarium care and contributes to sustainable and thriving aquatic environments. So let's move on to the introduction. So the purpose of this system is to care for the aquarium while the owner is not home in case of power outage. Thus, this system will automatically serve the needs of the aquarium, and the user can monitor and control it from anywhere from the world. The system will be able to feed lives using auto feeder, provide oxygen exchange in the aquarium with a battery-powered aerator, monitor water level tank, and able to water change according to the user's preference using Blynk app. So the problem statement would be improper feeding. So if the user forgets to feed the aquarium lives, or if he wants to feed in a certain way or certain times a day or certain times few days, so it will be difficult for him if he's not around. So it is improper feeding, then inadequate surface agitation leading to lack of oxygen. So if there's no enough surface agitation in the tank, there will be no enough oxygen being entering the tank. So this is also a problem. Or poor water quality without water change. So if the water isn't changed for a long time, the the nitrogen cycle uh, will will happen, and in the longer period of time the water will have more nitrogen in the water, leading to bad health for marine lives. So other than that, power outage leading to power cut of equipment. So when there's no power outage, the equipments such as the aerator, feeder might will go off, and it for the extended period of time there will be no oxygen exchange, no feeding, and so on. So the maintenance of the well-being of the aquarium will be affected. So the objective is to develop an automated system to maintain an aquarium's health, to develop a reliable aquarium monitoring system for users, to develop automated aquarium system that will be able to make informed decision and actions on its own during critical situations, to ensure the ecosystem in the aquarium is maintained. So this is the literature, the related works that I've compared. Similar projects of IoT-based automated aquarium systems. So aquarium monitoring systems based on IoT, aquarium monitoring system, smart aquarium design, fish stock. So these are all the previous projects that I related to. And for in common, they all have no power backup. They are not battery. They don't have battery powered aerator, and then most of them are high cost. Two of them are high cost, and then they have no aeration. Two of them got no aeration. So this is a important factor of the aquarium. So the IoT based automated aquarium care system has battery powered aerator, adjustable aerator, automated water change, auto feeder that we can be set for by the preference of user, and able to monitor the application, low cost. Other than that, let's move on to the methodology. So the flow chart will be to start initialize components means initialize serial communication, Blynk, and then Blynk timer. Then it starts to connect to Wi-Fi, starts Blynk, set up components, then goes to main loop, Blynk run. Then it checks for commands such as the feeding command, the command to run pumps, run aerator, and then so on. Then update sensor data, send data to Blynk, and then check for timer limit events. Then it will loop back to check for incoming comments, because it will always loop back to the check for incoming command, waiting for another command until it is disconnected. So there will be no end. And then next up, the block diagram. So this is the for the Arduino components. Arduino Uno is used. Then Wi-Fi module. The Wi-Fi module is ASP01S. So it will connect to the device. And then there's an aerator with a DC motor that can be PWM controlled. And then water change system, where two ultrasonic sensor is used to measure water level in the main tank and then the backup tank. The backup tank is used to add new water to the main tank. Then to the DC water pump, this is what withdraws water from the main tank out and then enters water in the main tank from the backup tank. And then auto feeder is used by servo motor. And then power system is it is powered by lithium ion battery. The motor driver for aerator is powered by lithium ion battery. And then 9-watt alkaline battery is powers the Arduino Uno, and then the water change system, motor driver for DC and DC water pump. And this is the Blynk application that is used for this system. So there are two feed here. So this feed, the feed one has an open time of delay of 0.5 seconds. And then the feed 2 has delay of 1 second. So what's the difference between 0.5 and 1 second? The open time. So when the open time is longer, the more amount of food drops. And then this is the speed control for the aerator, power on and off for aerator. So on tank level, main tank water level, backup tank water level, then this one water in and water out. So next up, results and discussion. So as I mentioned just now, water level monitoring, I've tested the water level monitoring where from the serial monitor and from the serial monitor, it shows the serial monitor and the Blynk app gauge varies. And the tank depth is also measured for an actual measurement of the tank depth is also measured using ruler. So all of the measurement varies. This table also shows the depth percentage where it is the serial monitor is printing. This is the gauge where the the Blynk app shows water level. So on auto feeder, there are this table shows first attempt of feeding with Blynk app. 3 attempts feeding is done, and the results are consistent and reliable. So after all the 3 feedings, all of the open time was the exact same as the actual one. The actual one was the exact same of the open time in the coding. Then next up, this table presents automated feeding where the time and day can be set. So I tested with various times being set, and the feeding was done properly. And then this not done here is because of the Blynk got disconnected because of poor internet connection. And another results is the aerator with lithium-ion battery. So the capacity of the battery versus aerator speed is tested. Tests are repeated 3 times with full battery with different aerator speed, 140, 70, and 10. And this with the results, it can be concluded that the when the speed of the aerator increases, time taken for the battery to deplete will decrease. It will not decrease, it will increase. Sorry, typo there. Later I'll change, madam. And then conclusion. In summary, the analysis of projects results revealed significant finding related to the water levels in the main and backup tank, feeding attempts, automated feeding, aerator speed, and battery life. The ultrasonic sensors accurately monitored and managed the water levels. The automated feeding system consistent and effectively provided necessary functions for maintaining the health of the aquarium. Overall, the project's contribution in the development of IoT-based automated system care that serves a reliable tool that will be a reliable tool for the aquarists. The systems can make informed decisions and take actions independently, ensuring the aquarium's management and maintenance even when the user is not around. The system is also equipped by battery to maintain stability during power outages. So these are the some of the reference that I used for the project here. Okay, all right, thank you.